I'm Shiv. I'm going to walk you through the journey that a customer goes through, right from day -n, all the way to day 0, day 1, and then Deepan and Ibrahim will take us through day 2 operational challenges. So before we do that, let's quickly talk about some of the network challenges today. I had gone for an RFP to a very large campus, and there they had brought us in to go and look at all the network, the closets, and give us a quote, right, the design. We had people with stacks of floor plans taking notes in there or on the iPad. Imagine sifting through that data just to put a quote, let alone do a network architecture, right? So the big challenge is in just getting the entire design done. RF results, today when we look at the site survey, it's all done, it's thrown over the fence. What happens to it, we really don't know. Was it deployed as per the plan, right? Those things really don't get into the deployment. Most importantly, how does the installer know how to go and install stuff? There are a lot of deviations from what we planned to what we delivered, right? The end result really here is we have coverage issues, right? We have performance issues, which leads to RF tickets, right? Our goal is to try and make sure that we can streamline this entire process. So let's start with the journey. The first step in the journey is for a customer to sign up on Nile portal. It's a customer-facing portal or an MSP. They go in there, they give us a site. Site is a logical construct, San Jose, New York. A building, physically this Hilton building, and a floor plan. And it's absolutely mandatory that is done, and you'll see why in a minute. Now, once that is done, this data now trickles into our backend systems. So we now have all this information, and we call this the customer management portal. This is not visible to the customer. It's more of a partner-facing and our service delivery managers who manage the entire process. There's a mobile app, which we call Nile Nav, completely revamped, launched a month ago. And we'll see some screenshots as we go along. But this is where you get to see those site survey jobs, right? The work orders, the cabling, the installation. So let's double click on a few of these. Step 1, I think all of us agree, a site survey is absolutely required, right? You cannot cheat on that. You cannot do a predictive and walk away. You need to do an AP on a stick, do the right thing. We use Ekahau tags to get some ceiling information. Net is, once you upload that file into through the mobile app into our backend system, we auto-generate a partial BOM. So no one is sending PDFs to the installer. All the information is flowing directly from the single source of truth, which was the customer who put that up there in the portal. So we have a partial BOM. You cannot place order yet because that's just a partial BOM. The next step is site discovery. Site discovery is really where the rubber meets the road. Go to that floor. Is there a closet on the floor? How hot is the closet? What kind of power outlets do you have? What kind of racks do you have? Where is the fiber patch panel? Is it an LC or ST, right? Or LC or SC? We show them images so they can easily pick it out, right? You have an OM1 fiber? I don't know what that is. Okay, what microns are written on it? Can you read that and enter that information there? Goal really here is, sorry, did I miss? Goal really here is to make sure that all this information is entered literally RU by RU. So that's the level that we can gather information with. And the result is we actually have a full BOM. A BOM is not just APs and switches. It's actually all the transceivers, all the patch cables that go along with it, all the AP mounts that are needed. We do firewall as a service. Even the firewalls show up on this BOM. Now you can place that order and ship the gear.
But just want to add one thing. So before we create the BOM, we create the digital twin of the network. We know exactly what's needed at the customer site. We create a digital twin, and that results in the BOM. Just wanted to add clarity to that.
We also give an AP cabling plan because there is a cabling job. You might have to redo cabling, or it's a greenfield deployment. Where do these APs go? Which switch do they connect to? You want 2 neighboring APs to be on 2 separate switches, ideally. So that plan is also provided step by step, including what mounts to use, including the AP height. So we have all this information available for the cabling vendor. We also provide a cabling interconnect, a closet interconnect plan. This is very critical. We all like to make those visual drawings where we say, strands going from building 1 to building 2 or 24. But how do they actually connect? It's not just going from building 1 to building 4. It's actually going to a closet. It's going to a rack. In a rack, it's going to a patch panel. All the information is provided here. And most importantly, we actually show this in the mobile app step by step. This is the new Nile Nav app that we've just recently launched, a complete revamp. Finally, we have a full-blown digital twin that comes along. So even before we ship all the gear, we know exactly how things have to be installed, how things have to be interconnected. And this is a screenshot from our third portal, which is the AI Operations Center, Automation Center that Deepan will talk about. So we've got the customer-facing portal, we got the customer management portal for all our site surveys and jobs, and then finally we have our AI Automation Center portal, which is purely internal. Great. So now we know that we have all the data to go into the installation. So now that job gets assigned to an installer. This installer could be a brand new installer because sometimes things get subbed out. They accept the job and they start with what do they have to do? What is all the gear that they have? Is it scanned, not scanned? Is it up? Is it operational? All that data is in here. They can literally go and take inventory from the pallet to identify what we have shipped. If there's any delta, automatically the delta is notified to us and we can ship more gear if need be. Okay, let's activate a single switch. This is an access switch. In this example, this access switch is going to be the gateway. What that means is it's going to be connecting up to the customer's router and firewall. So we are going to basically first go and unbox it. We'll give them step-by-step instructions on how to mount the switch, right? We've had instances where someone mounted the switch upside down, it literally fell, right? So idea is to provide them with step-by-step instructions. But the important thing here is we are not restricting the user over there, the installer. If you know how to install it, you can skip and move forward because when you go in production, when you are on the field, anything can happen. We cannot put restrictions. So this mobile app has been designed to skip, move forward. Obviously, the end result is before you close a job, all the deviations have to be accepted. So you could skip this step if you want. So here I go, I click on that device, I say I'm going to activate it, and we click on activate. You go to scan the QR code. Every single Nile element comes with a QR code. You scan the QR code. Once you scan the QR code, we actually connect through Bluetooth. We get the information on the version, etc., because this could be coming from a warehouse, maybe a year, 2-year-old code. We will notify the installer. It might take time because we have to go through an upgrade. And then we know where the switch is supposed to be placed, right? We confirm with the installer, this is where you're going to place it. Now, obviously, as you know, the RF plan says place the AP right here. When he goes to place it there, there's a big duct. He has to now move it, right? So he has an option to move. He moves it 30, 40 feet, assuming we can triangulate and capture it, that deviation would be there. So you can actually zoom in and say exactly where that device is going. And this is very, very critical. We do not let them install the AP without placing it on a floor plan. Now, this step is optional and is only required for gateway devices. So if I have 2 access switches and 10 APs, the access switches are connecting to the upstream router. You would put this information there versus if I have 2 distribution switches, rings of access switches and APs, you don't have to push any config to the access switches and APs. It's pretty much beep and scan. Here, all we're saying is give us uplink 1 information, uplink 2 information, because we're connecting to your router. Give us a subnet on which we can run a DHCP on our boxes and give our IP addresses to our devices. Give us NTP, DNS, and that's pretty much it. So the effort to bring up 2 switches and 10 APs versus 2 DSs with multiple rings of access switches and hundreds of APs is almost the same from a bring up perspective. We push that config through Bluetooth, and once that's done, we basically are good to go, right? Now, this is that Uber car that is waiting for you, but you get to choose your destination. You get to choose how many bags you're going to bring, how many passengers you're going to bring. So now you jump into the portal as a customer or as an MSP. You identify what kind of SSIDs do you want? How do you want to authenticate, right? Do you have radius servers that you want to put in there? Your DHCP server, or you can use Nile's DHCP server. How do you want to integrate with a third-party SIMS platform, whether it's Splunk or you want to generate tickets into ServiceNow? All that stuff is done through the portal, which you have control over, right? So to Suresh's point, we're not an MSP. We give you full control and visibility. So talking about visibility, this is our dashboard, the landing page. It's been designed primarily to answer one question. Is network the issue or not? Which is the Nile network, essentially. If it is not, is it your infrastructure that is the issue? If not, are your devices failing? Or are the applications a problem, right? So let's double click on this. Tile 1, which is Nile, Tile 2, infrastructure, and Tile 4, which is applications, is proactive monitoring. Minute by minute, we have data about every single transaction that we're doing. What that means is we need sensors. So the first sensor we have here is a physical sensor. As you can see, it's wall pluggable, no Ethernet port. You just plug it in, it connects to the network, and it's constantly monitoring the network 24/7 every single minute. And our SLA data comes from this sensor. Now, this sensor will work even when the internet is down. What that means is that it keep testing the Nile network. Internet goes down, it starts buffering the data, and then it sends the data up once the internet is up. What we're getting is, do I have 5 bars of signal or not, right? Negative 67 dBm or better. Is Nile, the NSP, the Nile service block, available or not? Obviously, we cannot place these sensors everywhere because it is dependent on the power outlet. So we have the exact same 1x1 radio in the AP. So it's the third radio on a Wi-Fi 6 AP, on a Wi-Fi 6E. It's a 4th radio. Sorry.
That sensor connects only via Wi-Fi, or is there an Ethernet option or a 4G or 5G option on the sensor?
Through only Wi-Fi. It only connects over Wi-Fi.
Okay.
Yeah. So the third radio of that AP is doing the exact same thing, and we are testing the Nile service block. So on a specific floor, if I had 10 APs, I'll probably have 15 or 20 sensors, depending on how many sensors I could plug in here. So it's giving a good enough data to at least characterize this entire floor, right? So that's basically our sensors from a NSP monitoring perspective, which gives us data for the Nile tile, availability, coverage, and capacity. The third sensor is sitting in our switches. It is doing an actual radius transaction with your radius server on UDP 1812. You give us your MSCHAP v2 username and password. If you create one for us, it'll be a successful transaction. We'll tell you if a service is up, and if it's up, what is the latency of that service. Same thing with DNS, same thing with DHCP. We also do HTTPS transactions with top 10 applications, only business applications, so Netflix won't show up there. We can even customize those applications if customers have HTTPS-based services. But net, all the data that you see over here is coming from proactive monitoring. So if that radius server goes down at 2 a.m., at 2:05, you will have a ServiceNow ticket or an alert sent to you. You will not wait till 8 a.m. and 25 clients failing to tell, oh, most likely it is your radius server that's failing. AI cannot help here, right? This is where AI is going to look at that data and say, oh, I think your radius server just failed, rather than why even bother using AI when you can actually do proactive monitoring. It's one transaction per minute. It gives you your latency and your service status, right? You see devices has DHCP, DNS radius repeated. Reason is, if your radius server goes down and you haven't taken action, what is the impact on the network, right? Every single transaction that fails will start to show up here. Finally, you can see all the SLAs. Our definition of SLA is 99.95 per building per month. If we go below 99.95, there's a service credit that will be given to you. Now, we spoke about the whole Nile network on how we have zero config, how we have zero trouble tickets. That was all about Nile, and Deepan and Ibrahim will go deep dive into what that means. But when it comes to context, right, my camera cannot connect to the DVR. That is still going to come to your help desk as the first call. And this is a real-world example where the camera was not working. You can go to the camera. Since we are the default gateway, we can do a ping. Ping failing is not a bad thing because sometimes it could be blocked. We do an RPing to verify that that connectivity is still there. We get data from our sensors to show everything looks good. Then you can do some on-demand tests. Let me ping my DVR, right? It failed. Let me do a trace route. Where did it fail? At the firewall level. So that is how we were able to figure out that during migration, they forgot to put a firewall rule. We will be adding some port level tests as well because pings are not the best from a testing perspective. If this client didn't get a DHCP transaction, we can do a synthetic transaction on behalf of the client because we are going to be the IP helper. Again, we are the default gateway. We use the source IP of that subnet and do a transaction to see if the DHCP server is responding or not. Finally, we also want to make sure the burden on your IT as a customer is reduced as much as possible. So right now, if you connect to the Nile network over here, you can navigate to my.nilesecure.com. So any customer who has a Nile network can navigate, and you would get a screen that looks something similar. We try and keep it in plain English because everyone is not tech savvy to know what MAC addresses, IPs, and signal strengths are. So you see, you have video conferencing signal. That is what we are stating here because you have negative 67 dB or better. You have negative 72, it'll go orange. You have web browsing capability. You're a sticky client, and we know for sure you're a sticky client because the AP is right up there and you're connected to the AP down the hallway. We'll say, please disconnect and reconnect again. If you still don't know what the problem is, you click on need more help, and it'll have a pop-up. Assuming you have a webhooks integration with ServiceNow or any other tool, we can create a ticket directly from here by taking a screenshot of this page. Most valuable could be that speed test because you cannot invoke remote speed test on someone's laptop, right? So they can open a ticket. We will give them the ticket number. Obviously, an email will go to them, and then that gets escalated on top. Quickly, just want to, sorry, go ahead.
So when something legitimately breaks and it can't be figured out, who fixes it?
Yeah, so there are two parts to this. One is it a Nile issue or is it something to do with the context, right? So let's say if it's a Nile issue, usually Deepan will go into more details. If it's a Nile issue, we are getting a lot of metrics, and he will show you some of the data where we probably know in a matter of a minute or 2 minutes or 3 minutes something has happened, right? Obviously, if they call in and we have missed something, it is software, we could miss stuff, it'll get handed over to us from a support perspective, and we'll take care of it.
Right, but that's what I'm saying. Who is we?
We means Nile. It's not even the MSP, it's going to be Nile who will take care of it. If it's a Nile issue, if it's an AP issue, beacon stuck, buffer overflow, CRC errors, anything that's causing the network service to get impacted, it is Nile's responsibility, not the MSP or the partner or the customer.
So when a rat chews through the Ethernet cable, whose responsibility is that?
If the rat chews, it's an environmental issue, so it is the customer's responsibility.
Okay.
So power, temperature in a rack, cable, someone cuts fiber, that all is going to be the customer's responsibility. Anything happens to our equipment because of software issues, hardware failures, completely on us.
But more importantly, Sam, to your point, we inform the customer exactly where the problem is because we are constantly monitoring it and tell you exactly what needs to be done. And the other one is the physical one, but in meantime, our automation is automatically rerouting around that failure and providing seamless experience if there is an alternate path. But in the interest of the time.
Yeah. So I went through day 1, day 0. Now I'm going to have Dipen and Ibrahim take us all the way through day 2. This is all about those issues, right? How does Nile tackle Nile issues, right? That core block, the Nile service block, and I'm going to hand it to Dipen. Thank you.
I've got a quick question about the sensors that are actually doing the testing. Are those simulating different client types, like what Apple would have and what Windows has from authentication, or is it just the same base across all of those, and that's kind of the known good client?
Yeah, it doesn't simulate different types of clients today. It is basically whatever chipset it has. It's not simulating like a Windows versus an Apple. Not today.